Hello, I'm Anusree Sajeevan, research scholar from Quorum Sensing Lab, working under the supervision of Professor Adline Princy. I'm here to give a brief overview about my thesis work titled Vibriocid, a targeted oral antimicrobial product for cholera management. So why do we address cholera? Because as per the global statistical report, the cumulative death and cumulative cases due to cholera outbreak strains was approximately found as 7.5k and 603.2k across globally. And even though there are several treatment strategies are available for cholera diarrheal diseases, there are numerous challenges existing, including an emergence of antimicrobial resistance due to overuse of antibiotics that make limited efficacy of other existing treatment strategies. So to find out a permanent solution for this, we have come up with an idea that is a therapeutic innovative approach that developing a pH responsive dual drug nanocomposites named Vibriocid. So basically we have developed a pH responsive polymer that encapsulating dual drug. One is quorum sensing modulator named as a pyroxene dicarboxylic acid, and another one is a failed antibiotics, that is doxycycline. So the rationale of choosing a quorum sensing modulator, because as we know that Vibrio cholera is the pathogen behind the serious diarrheal infection. So Vibrio cholera possessing a well established quorum sensing system. So if we consider a modulator which can control which can regulate this quorum sensing system, will be a promisable approach for combating Vibrio cholera infection. So based on our preliminary data through our in silico analysis, we could prove that this PDCA PY can effectively bind with a global response regulator named as LUXO in Vibrio cholera pathogens. So since it is effectively targeting LUXO, thereby we can confirm the biofilm inhibition and regulation of all other virulence factors. And also in this current study, we could prove that this PDCA PY can enhance the potential of failed antibiotic doxycycline. Thereby, this dual drug approach will make sure the antibacterial and antibiofilm property against Vibrio cholera pathogens. So for synthesizing a Udragid based formulation, we have approached a nanoprecipitation method. So these are the findings that we received from our observation. After treating with Udragid encapsulated dual drug such as doxycycline and PDCA-PY, both biofilm as well as the planktonic cells are getting inhibited, and so we could confirm that it has a prominent bactericidal as well as anti-biofilm property. As per the technology readiness level, currently we are at developmental phase, and prior to scale up and clinical studies, our formulation has to be validated with a suitable animal model. And in this forum, I would like to acknowledge SASTRA University for providing me infrastructure for completing my research work. And sincerely, I wanted to express my gratitude to my supervisor, Professor Adline Princy, for her immense support throughout my PhD journey. And also, I wanted to mention my collaborators, Dr. T.N. Ramamurthy from ICMR Kolkata, Dr. Suma Mohan and Dr. Rajesh for their valuable suggestion and feedback. And also, I am grateful to Quorum Sensing Lab members for their support throughout my PhD work. Thank you.